This video is about converting absolute values to piecewise defined functions. So with absolute values, you already know that you plug any number a in here, it's going to turn out to be positive. So what we need to do is make the absolute values work the same way without the absolute values. So if a is greater than 0, that would be a number like 5. 5 is greater than 0. You don't have to do anything to 5. It's always going to be positive. But if you pick something less than 0, like -2, then the absolute value is going to turn it into +2. So we need something else that when you plug the -2 in, it turns it positive, and that is a negative. So if we use -a, it works exactly the same way as an absolute value for numbers that are negative. So the way I like to look at it is it's like absolute value is like Happy Land. It's like going to Magic Mountain. If you put a positive person into Magic Mountain, he comes out positive. Put a negative person into Magic Mountain will do its magic and turn him positive. Well, you got to think of something else. What else would make him positive? A little cotton candy, right? So if you give a negative number, the a is negative here, a little cotton candy, he also turns positive. So Magic Mountain and cotton candy are equal. They work the same way. So Magic Mountain or cotton candy, you're going to turn a negative positive. So that is our piecewise. So if you look at it with a variable now, we have absolute value of x. All the positive x's are going to stay positive, but all the negative x's will need a negative to turn them positive. You can also look at this graphically. The absolute value has a v. We know that that is 0 here, right? And so on the left, you can see that that is a negative slope. That is y equals -x. And on the other side is a positive. That is y equals x. And so all we're doing is taking the absolute value and breaking it into the two linear equations that they have for less than 0 and for greater than 0. And it doesn't matter where you put the equal. They're both equal to 0 at 0. So you just have to put it on one of them so that we have a nice continuous function. So you can put the equal here or here. It's the same, but you can see that less than 0 we get -x, greater than 0 we get +x. So either thinking of it as cotton candy and Magic Mountain or as a graph, it's the same thing. So let's try some. I'm going to show you two different methods. This is method 1 and method 2. Method 1's the very quick one and it's just a thinking method. Method 2 is the brute force method, but they both work. All right, so we have absolute value of x minus 3, and this is our piecewise defined function. So I'm going to show you where it comes from. So here is the graph of the absolute value of x minus 3. You can see our v. It's been shifted to the right 3 because of the -3. So if you look at it, we have the negative x minus 3. That is the one on the left. And the one on the right is the positive, because everything greater than 3 now, when you plug it in, will come out positive, like 4. What's 4 minus 3? It's 1. 5 minus 3 is 2. Everything greater than 3 will work out positive, and everything less than 3 is going to come out negative. So if I were to plug in 2 minus 3 is -1. The absolute value kicks it back to +1. So we need to have that negative here as well to cancel that negative output. So distributing a negative, we get this. Distributing nothing, or a 1, you get this. And so these are our piecewise defined functions. So you're thinking of the absolute value as two linear equations. One with a negative side, and one with a positive side. So simplified, we get x minus 3 equals x minus 3 for x is greater than or equal to 3. And negative x minus 3 for x is less than 3. And so now that you've seen it, we just do the same thing. If you have x plus 4, it'd be x plus 4 for x is greater than -4. Where did I get that? Remember, it's shifted to the left 4. And we get negative x plus 4 for x is less than -4. And it doesn't matter the order here, so you can even put them on top. It's usually best to put the negative up here. And what I mean by the negative is the negative inputs. Well, the outputs, and then x plus 4, like that. And then we put our little brace. So there you go. There is our piecewise defined function. Now, if you switch them, this is a -x, what it's doing is, again, rotating it. And so our v here is going to look like this. It's still shifted to the right, too, because 2 minus 2 is 0. But what's happened now is, look, here's the negative, which used to be on the left, and now it's on the right. And the positive, which used to be on the right, is now on the left because it's been rotated. It's been rotated about the y-axis like this, and so now everything's been switched. But all you have to do is think, oh, well, if it's switched inside, we get a negative x, right? Now then positives are negative, and the negatives would be turned positive. So everything's backwards. So all you have to do is switch the sign. So instead of putting the negative on the minus, on the less than 2, you put the negative on the greater than 2. That's it. And so it's backwards. That's all it is. So if they're backwards inside, they're backwards when you write it. So we end up with the absolute value of 2 minus x is equal to, and then it would be 2 minus x, I'm switching them, for x is less than 2, and negative 2 plus x for x is greater than or equal to 2. And it's very quick to check. All we have to do is think of a number less than 2. So if we have x is less than 2, that would be like 0. So if I plug 0 into 2 minus x, it should come out positive. See, positive 2. And then if I use something greater than 2, like 3, I would get negative 2 plus 3. So I'm plugging it in that one, and you see it equals 1, which is positive. Everything is checking perfectly. If they both came out negative, you know you had them backwards. So again, if it's just x plus 4, you put positive x plus 4, x is greater than negative 4. Negative x plus 4, x is less than 4. And if it's backwards, like 2 minus x, then you just want to switch them. So now the positive gets the negative, and the negatives get the positive. Okay, so let's have you try these really quickly. If you don't like this method, again, I'm going to show you a second method, and you can try it again. So hit pause and give it a shot. And there you have it. So the negative would be for the less than 7s, and the positive would be for the greater than 7s. And again, these are backwards. So again, you can check it. If something less than 9 would be 8, so 9 minus 8, it's already going to turn out positive. Something bigger than 9 would be 10, so 9 minus 10, that's a negative. So we need a negative to counteract it. So on. So if you got this, you're good. You don't even need method 2. Just move on to the next video. But if you still don't really understand this, let's try method 2. So method 2 is the brute force. All we're going to do is the same thing we kind of talked about. So we're going to put x minus 3, and we're going to keep it positive for the greater than 0, and negative for the less than 0. So we're going to put a negative here when it's less than 0, positive when it's greater. And all I did was take whatever's inside and rewrite it. So it's x minus 3, x minus 3, x minus 3. And then same thing here. This is negative x minus 3 for x minus 3. And then we just simplify. So we would end up with x minus 3 is equal to, and then this would be x minus 3. And now you just solve the inequality. So plus 3 plus 3. So x is greater than or equal to 3. And then this would be negative x plus 3, and we do the same thing with that guy. So x plus 3, it's less than 3. And all you don't have to do now is basically just rewrite it and simplify, and it tells you the piecewise. So the same thing would happen here. This is 2 minus x, so we'd put 2 minus x and 2 minus x. One positive, one negative. And we put the 2 minus x again here with a greater than 0 for the positive and a less than 0 for the negative, and we simplify. Like that. And so for the top one, it's greater than or equal to 0, minus 2 minus 2. And if you remember, if you divide by a negative 1, what happens to the inequality? It flips. So now it's less than or equal to 2. So we write less than or equal to 2. And then you know this one's just greater than 2. You don't have to actually solve it. But you do want to check it. So something bigger, less than 2 would be 1, or 0. So if we plug it in, we get a positive, check. And if we plug in something greater than 0, like 4, we also get a positive, so we're good. There we go. That is our piecewise defined function. So now I want you to try it here with these two. Same exact method. Hit pause and give it a shot. And so those are your answers. And again, they should match the ones above. 9 minus x for x is less than 9. 9 minus x for x is less than 9. And negative 9 minus x, negative 9 plus x for x is greater than 9. So everything checks. This one as well. The negative gets the negative, the positive gets the positive, and so on. Thank you.